Today we will talk about basics of matrix operations. So let's start. I am going to replace clear all with simple clear. It will do the same as clear all, close all, and then clear screen command. Let's save this first. Basic operations OP. So first of all, we will see syntax of a matrix. Let's say we take a matrix A. Syntax of matrix, we can write a matrix by using some commas, and we can also use, this is a matrix A I am having. Let's run this by using F5 command. Here I am having a matrix A 1 2 3 4 5. Again run this 1 2 3 4 5 in workspace. If I want to see these are the values of that very matrix A consists. So if I am using simple space instead of semi commas, then it will do the same. So here I am having matrix 1 2 3 4 5. Again test this matrix. Then there is a function. If we want to check the size of a matrix, then what we will have to do, the size function returns the rows and column. So rows columns equals to size of matrix A. Size of matrix A. Let's run this. Here I am having only one row in matrix A and 5 columns. So let's check this. R equals to 1, C equals to 5. Okay, and if I don't terminate this line of code, then I will get the result direct in command window. Here you can see R equals to 1 and C equals to 5. Then if you want to make a matrix, if you want to make a matrix of zeros, let's say someone says you to make a matrix of zeros of order 1000 cross 1000, it is not possible for us to make a matrix of zeros in a limited time of order 1000 cross 1000. Let's say I am specify here 10 cross 10, and I am storing it in matrix A. Here I am having a matrix A of 10 cross 10. Here you can see also a matrix A of 10 cross 10 in the form of a spreadsheet of zeros. Now if you want, if someone says you to make a matrix of 12, then what we'll do to make this matrix, add 12 in this matrix of zeros. Now let's check this matrix A. Now this is a matrix of 12. We can also do this by using a matrix of ones, but in this case we will have to multiply 12. For multiplication, use static. Now test this matrix. Sorry, OMES ones. Let's run this. F5. Here I am having in workspace. Now I can test this in command window. Now you can see both does the same. Now if you want to perform addition, For addition, what is needed? For addition, order of matrices must be same. What does this means? A equals to, I am having a matrix A, let's say of order 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's copy this matrix, control C and control V, name this B, capital B, and store the result of this addition A plus B. If I don't terminate, then I will get the result in command window of addition. So here is the addition. You can see 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6, 4 plus 4, 8. If I terminate this, I won't get the result in command window. So you can see, to check this, I have to do this. Similarly, as I talked earlier, if we want a matrix of scalar, if we want a matrix of scalar, let's take another matrix. Let's say A equals to, we have a matrix of ones of order 5 cross 5. We can also use 5, 5 and simple 5 simple 5. This will also give us a matrix of order 5 cross 5. So here you can see capital A is a matrix of ones of order 5 cross 5. Now if I want if I want a matrix of 12, okay, let's copy this, control C, control V. Let's say this is a matrix of zeros, ZERO as zeros, and this is, we have matrix B, and let's say C equals to A plus B. Now the addition will give us the result 12, because this is a matrix of 1 and this is a matrix of zeros. We can do the same for subtraction. For multiplication, we have to use static. Now we will get a matrix of zeros, because 1 multiplied by 1 multiply 0 will give us result 0, and in the same way we can divide A divided by B equals to 5. Now this is A divided by B will give us what? Infinity. You can see 1 divided by 0 will give us infinity. If we use this type of slash, then we say this right division, and its result is this. And if we use this this way, then we will get no result, no answer. Okay, will show you in a different way. A is a matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. A, control C, B, control B, capital B. The result should be stored in. Now, if I change this to 11, 12, 13, 14, 15, 16, 17, 18, 19, and if I divide this by using this type of slash, then what we will get the result 1 divided by 11, A divided by B. This will give me the result A divided by B, F5. Now this is giving me the result A divided by B. And in the similar way, if I do this C equals to A, this type of slash, capital B, now this will give me the result B divided by A. Okay, so here I am having B divided by A, and in similar way we have dot division and dot multiplication of matrices. Let's say we want to get the result of this, and let's comment this control R, and we want B by A. So here you can see B by A, 11 by 1 equals to 11, 12 by 2 equals to 6, 13 by 3 will give result 4.3. In the same way, we have dot multiplication, dot addition, and dot subtraction. Let's do this. For multiplication, A dot steric B. Now check the result. Oh shit. Check result. Here I am having a point by point multiplication of both the matrices, and its result is stored in C. So similarly, if we want to add, addition is the point by point, always point by point addition and subtraction. So here we have a function. Here we have a function of length. Let's say I want to check the length of matrix C, LENGTH of C matrix, but here I am having 3. Length of matrix C is 3. Now let's check this matrix C. Length of matrix gives me the order 3 cross 3 of this matrix C. In the similar way, if we want to check the length of matrix A, LENGTH, let's check the matrix length of A. Sorry, yes, length of matrix A is also 3, means it is a matrix of 3 cross 3. Let's clear command CLC. Now we will see. Let's say if we want to see the diagonal, if we want diagonal of matrix C, what we will have to do, we will use a function dig of C and store in capital C. You can see the practical example of case sensitive language MATLAB. Here I am using capital C and here I am using small c. Both have different results. So DIAG diagonal. Yes, here you can see the matrix C, and if we want, let me show you matrix C. What was actually matrix C was we have matrix C 11, 75 and 171, and here we get result of diagonals 11, 75 and 171. And let's comment this if we will use further. If you want to uncomment with a single shortcut, then you can use Control D to uncomment and Control R for comment, Control D for uncomment, Control R. And let's say I want to have a row matrix, but use space. Here I am having a matrix, row matrix. Okay, let's check the size of matrix A. Size of matrix capital A 1 cross 9. I am having a row matrix of order 1 cross 9, and if we want to convert this into a column matrix, what I have to do is to simply use, let's say I'm having a column matrix of order 9 cross 1 of the same fashion as A. What I have to do is I have to use apostrophe for this. B equals to A apostrophe. No. Let's check the size of matrix B. Size of B. Size of B is 9 cross 1. And if you don't want to use apostrophe, simple use transpose. It will return a column matrix of 9 cross 9. Size of B is 9 cross 1. Now, if I do this, let's comment this. If I want if I do sign of matrix A, it will give me the sign of matrix each and every value. It will give me the sign of every entry of matrix capital A. Let's see this matrix A here. Let's change this to a square matrix. Here I have A. Now you can see here I am having a matrix of signs of capital A. In similar way, we can take cosine B, change here sine to cosine, and here I have. Let's undo this by Control Z. Now, if you want to make an identity matrix, for that purpose we can use function IEYE. If I want to make an identity matrix of order 3 cross 3. I just have to simple write 3 in here and it will give me a identity matrix of 3 cross 3. Let's check here. Here I am having an identity matrix of 3 cross 3. Let's take the inverse of this matrix. Remember this, for inverse of a matrix, the matrix should be a square matrix. Let's INV inverse of matrix capital A equals to small a, and let's do this. Semicolon F5. Here I am having matrix of inverse of 1. You can see what I will get. Inverse of matrix, identity matrix is always identity matrix. To see this, let's use this matrix. This matrix A, small a equals to INV of capital A. This let's check here matrix A. Here I am having matrix A. Let's change this 11, 33, 55, 12, 89. Let's start this. I want to actually remove that warning so that we get scalars possible. Here I am having the inverse. Now we have property, if we multiply a matrix by its inverse, it returns us identity matrix. Let's prove that. B equals to A multiplied by inverse. F5. Let's check B. We are having here. You can see we are getting an identity matrix. Let's change this capital A multiplied by small a. Now change this and check the result. B. It does the same. Now if I want, let's take a simple matrix. Yes. Let's take a matrix A. Now if we use a function sum of A, small a equals to sum of A, sum of A, sum of A. Let's run this. Let me tell you one thing. If you see here, we are having a static in our editor window, and same is in current folder window. Okay, it means that we have not saved our code after changing this. Let's save this first by Control S. It's a good practice to save. Otherwise, when you run it will automatically be saved. Let me tell you one thing. First, let's check matrix A. Now check matrix small. By using function small a, what we get? 7 plus 4 11 plus 1 12, 8 plus 5 13, 13 plus 2 15, 9 plus 6 15 plus 3 18. So function sum returns column addition of matrix A. Okay. Now this is column addition. Now if we want row addition, what we will have to do? Then sorry, in editor window, then we have to take the transpose of this matrix and then use the function sum. Let's do this. Capital T equals to a apostrophe sorry, a apostrophe semicolon, and here we have capital T. Now let's check capital A and small a, capital A then small a. Here you can see 3 plus 2 5 plus 1 6, 6 plus 5 plus 4 15, and the result of third addition of third row is 24. This is the row addition we have. Now let's see the multiplication of two matrices. Let's say we have a matrix. So use this control C, control V. Clear command. Let's check the sizes of both these matrices. Size of A is 3 cross 3. Size of B now you can see the practical example of if we are having a workspace variable and then we can test that variable in command window. I use this in editor window but didn't execute this code. Now first of all, for that purpose we have to first run this code and then we can test in command window. Size of A, size of B, 3 cross 3, 3 cross 3. I want to show you something. For that purpose I check the sizes of both these matrices. Now for multiplication we know that that we should have, for multiplication, column of first matrix must be equal to the rows of the second matrix. If that doesn't meet, if that condition doesn't fulfill, then we will have a dimension error in MATLAB. Let's check this. If I am having C equals to A multiplied by B, no, here we will get the result because the number of rows of the number of rows number of columns of the first matrix are equal to the number of rows of the second order. 3 cross 3, 3 cross 3, then we will get a new matrix C of the same order 3 cross 3. Here we will get the result, but I want to show you this. If no, here we are getting dimension error. That I want to tell you. So in this case, here we can see the practical example of dot multiplication also. Let's do that. Dot multiply by B in a clear command. Now run this. Small c is different from capital C. Let's check this. Small c will give multiplication rule give the result of multiplication according to multiplication rule, and Dot multiplication will give us point to point multiplication. 1, 11 multiplied by 1, 11, 12 multiplied by 2, 24, 13 multiplied by 3, 39, in the same way. And let's comment this. Let's move further. Let's say if we want to take the determinant of matrix A, then we will have to use the function det of capital A will give us the result. Let's run this without using dets. So you can see I am having the determinant of matrix A. And if we want the eigenvalues of matrix A, then we will have to use the function EIG. Eigen function returns us eigenvector and eigenvalues. For that purpose, we have to declare two outputs. Let's say small v represents the vectors, and vector, and let's name is small a. Run this. Here we are having eigenvector of matrix A, and corresponding to the first eigenvector, first eigenvalue corresponding to the second eigenvector, second eigenvalue, and so on. So let's end this here, and we will cover the next in coming